Okay, folks, it's 5 after. Let's get going. Thanks for joining. So people want to talk about what they were able to try or achieve last week.
I still haven't managed to make any submissions, but I've still been working along sort of with the idea I had a couple of weeks ago to sort of try and split the spectrograms just down into like individual species and just do a classification per species. I could share my screen here a second, just show you where I've got to. Can you see my notebook here? Sorry.
Yes.
Yeah, so like it's, as Alex had said a couple of weeks ago, like each species is sort of tends to be within a band, like within upper and lower frequency. So from what Alex had said a couple of weeks ago as well, yeah, with his help, I was able to like use this mel frequency band thing. And so like it would tell me which bands correspond to which frequencies. And so then I can just pull the band out for each species. So for example, like this one here, I think that's species 14. This is the whole mel spectrogram and the whole time span. So you can see here, it's just within like this little horizontal band. So yeah, like then I can just chop off the top and the bottom to leave the band that this would be in for the classification problem. And then, yeah, so like that greatly reduces the size of this. So I can then do that for every single species. So you can see here, like these are like the first examples out of the training set. So now I've got, so I just take the mel spectrogram array that I've pre-generated and like dump the green or the yellow bits just to leave the thin band. And like then it's just gonna like run a classification each one. The only problem I have is, yeah, so I haven't actually sort of been able to classify on these yet. And part of the problem I'm having is some of the species, their bands is very, very thin, like between the max and the min sort of top and bottom frequencies. So you end up like with a very thin band, which it's only got, in one of the species cases, there's only like 11 mel spectrogram bands. And so I end up with like very long arrays, which are only a few pixels high. So I wasn't sure about like what type of CNN to use on that, because of the fact that, yeah, like I tried down, I've got like yeah, like a simple network down here, which is just like a 3x3 convolutions, and then it sort of pools and then sticks another 3x3. But because of the fact it was only 11 pixels high, by the time I've done this and this one, I end up, I've only got like a very, very long thing, which is only 1 pixel in height by the time I get to the linear layer. So I'm not sure how well that will work, or if there's a better way to sort of deal with images that aren't sort of more square in nature. But yeah, I haven't got very far with that yet, so but that's where I'm up to so far. So
do you train separate model for each class?
Yeah, but because of like I've got like each species has like a different height in its mel spectrogram image after I've chopped the top and the bottom off. Yeah, I was just going to have like a separate network, one for each species. I wasn't sure was it possible to have like one network that would work for every single one, seeing they've got like different shapes in the input.
And for each model, you feed in a whole recording clip to protect one class?
Yes, that's right. Yeah. So yeah. So yeah.
My thought is that if you do in this way, on one hand, you only encode the useful spectrum is only a very tiny portion out of the whole clip. So it may not be pretty efficient. And on the other hand, if you do it this way, it's easy to go out of memory, particularly when you go in batch wise, because your whole clip is only lasts for 60 seconds long. So the way I think is it may be better to crop it instead of using a 60-second. You just localize it because you have the bounding box, right?
Yeah.
If you don't consider, so I think it's okay to just pad to mask the frequency at the moment. But for the time interval, I think it would be more efficient to just crop it around the bounding box.
Do you mean just like do slices of time? Chop? Yeah, so at the minute I've cut it vertically, so I've only got like the band. So like my the image that's coming in is like only a one channel image, and it's maybe 3,000 pixels wide, but then it's only like 10 or 11 pixels high. But yeah, do you mean like chop it into time slices, like do sort of 10-second tiles or something like that?
Yes. So instead of feeding the whole recording clip, you feed in the subclip into it, because you have the bounding box. So you know which time region the species is responsible to. So you can just crop that region. They may have different time period, but since you have 24 model for each, so I think because for this competition, I think the setting is each species should have the same time interval. For example, class 0 may have every class 0 will have the same time interval. So if you crop it in this way, I think it should be fine because they will have the same size.
All right, I hadn't realized that they had the same time interval as they have the frequency band. I hadn't looked yet like the time.
Yeah, they will have the same duration.
All right. Yeah, I'll give that a go then. Yeah, like that would sort of help things a lot probably, because as I say, at the minute it's been hard sort of dealing with very skinny long input images or whatever. So yeah.
Yeah, and I think if you're doing this way, it will train for, on one hand, memory rise is very sorry, it's very expensive. Another thing is if you train in this way, it will take pretty much time because your model is probably to be big because your input is big. And do you trying to train your model from scratch? Because I see you define the model block.
Yeah, at the minute I just like had like a basic CNN that I was going to train from scratch just as a sort of baseline. And then yeah, sort of work from there, and like then maybe sort of employ some sort of pre-built and pre-trained image model. But yeah, I just thought I would like sort of try with a sort of handcrafted one to start with.
Okay. Yeah.
The only thing also is if you chop, Steve, then when you predict, you'll need to do the concatenate or assemble them together for the 60 seconds, since you'll have to predict for the whole output.
Yeah, like that's sort of the reason why I hadn't sort of sliced it into time things, because I thought if I don't slice it into time, then when it comes to the test set, I can just give it like the whole minutes input and it'll just be a binary classification on it.
Yeah,
but actually stitching it together is not that. You can just concatenate and predict, so that should work since you have like also 24 predictors running in parallel anyway.
Yeah. Yeah, so hopefully this week I'll get more time on it, and hopefully by next week I'll actually be able to submit something from this.
Yeah, just to add a bit on the cropping thing, like if you try to crop the duration, then you need to do some heavy lifting work on the inference, because in the training time you know where to crop, but in the inference you don't know. So you need to have some sliding window on your inference.
Yeah. So like that was like sort of why I'd sort of tried to avoid it to start with, because I wasn't sure sort of what the gap should be between the sliding window. Yeah, because like obviously, as you say, like on the training set, you know exactly which bit, what time interval the thing occurred at, and so it's like easy to sort of chop up that way. But
in this case, then if you have 24 model, then different model will be responsible for different duration. So each model will have their own sliding window size.
yeah.
So, and also you need to determine the hop size, something like that. Like,
Okay. Yeah. So anyway, that's as far as I've got, and I can try all these things during the week and hopefully get somewhere with that.
Thanks, Steve. Anyone else? Alex?
yeah. Wait, let me share screen. Actually, this week I didn't do much because I spent most of the time refactoring the code. Because originally my code is all written in Notebook, which is quite messy. So spent quite some time to refactor them into a repository so that later on I can easier to maintain that. So since I don't want to waste the GPU limit for this week, so what I essentially do is I just try to do the 5-fold. I try to run my previous experiment in 5-fold. So my previous experiment is I try to set the ML to be 256. So I try to run it 5 times, and then I try to do some example based on this 5-fold. So if you look at the submission I highlighted, they are responsible for different fold of my same configuration. So essentially, I just use my baseline. I use ResNet 34 train for 10 epoch with on the head, and then train for the whole body for 20 epoch. So in total, there are 30 epoch, and I only use true positive. So these are the 5-fold results. So you can see it has pretty high variance. The minimum LB score is something like 0.77. The highest is the 0.81. I would say the variance is pretty high. So given, and I also noticed that the public LB and private LB is pretty close. I originally thought that the public LB should look a bit different from the private LB because the public LB has a way smaller sample size. And originally the whole sample size is particularly small. So I expect may have some outlier effect, something like that, which makes the public LB to be a bit different from the private LB, but seems not the case here. Because originally, if I scroll down to look at other submission, yeah, you see that in some case, like private LB tends to be higher than public LB. I'm not sure whether you encounter this case, but in this 5-fold, I didn't encounter that. So,
do you think it's just a coincidence? You see, each fold gets progressively better. Do you think that's just?
Yeah, I don't know why. It's not intentional because I do a stratify I do a stratify k-fold.
Yeah.
So I should randomly assign the validation set for each fold. So it shouldn't have some ordering which makes it progressively better. So I think it's just by chance.
All right. Yeah, it's just a bit strange that each fold gets slightly better.
It's a bit strange, like yeah, I can't explain why. That I just take it I just think it's by chance. So given this setting, since different model have a pretty different score, given this high variance, so I expect when I ensample them, I should give a way better score because I assume that each model is learning something different from each other, so they are not quite correlated. So what I do is, given these 5 submission, I take an average and just submit again. So this submission. So what I get is if I compare with the highest LB score of the 5-fold, I get a 4-point increase, so which is quite a lot. So if you compare the largest score on 5-fold is something like 0.81. If I do an example, it boosts up to 0.85. So it's quite significant. And I also tried the rank ensemble. This one is a failure case. I have some bug here. So I think this is the correct one. So if I do a rank ensemble, I think I get a similar score. But I would say average ensemble is better in this case. So the way I do the rank ensemble is essentially just for each submission, I translate each probability into a ranking. So it's an integer from 0 to 23. And then I use this rank and then I do a average across this rank. So just doing that. Yeah, and then yeah, so these are the results for the way I do ensemble. After I do ensemble, I further do some post-processing. So in my previous observation, if I do post-processing, usually I would get something like 4 points or 5-point performance gain, but in this case, it does not get much, only 1 point. So I think it has something to do with the model characteristic. If I ensemble them, I think the result is more stable, or I would say it has less false negative, I guess, because by the time I do the post-processing, it's trying to mitigate the cost incurred by the false negative. So I think that's the reason, I guess.
Alex, on your post-processing, are you adjusting for the frequency of those two classes that are low, or are you adjusting for something else?
So the way I do post-processing is, so each prediction is a factor, right? Assigning probability for each class. So we have 24 class, so it's a factor of 24 entries. So I will only apply the post-processing on the class whose probability is lower than 0.5. So those class that has low confidence. And then I will replace those probability by the class weight. So the implication is that those class which have a high population will bump up in the ranking. So that's essentially what I do. So the class weight is the class weight in test set. So in the first week, I do some LB plotting so I can guess the kind of the test set class weight. So essentially, I just substitute those probability by the class weight. Yeah, so essentially that's what I did, and then I'm also doing the FifO training on my another configuration. It's a configuration that I train the true positive and false positive together, and then I try to apply some mask binary cross entropy, but I think it's still running. It's running pretty slow because each run takes around. So I have 5 runs. Each run takes around 4.5 hours. So, but from what I see right now, you can see this is the validation LW wrap. You can see the variance is actually pretty high as well. So I expect in this case, if I ensemble them, I will also get a significant boost. And then you'll see, like, if I, so the 5 runs that I highlight is the 5-fold that I do on the, that I mentioned before. Essentially, I just change the ML and using the true positive. You can see the runtime is something like only 30 minutes. And then if I combine, when I combine with the false positive sample, the runtime significantly increase a lot. So what I essentially do is I just try to pre-compute the spectrogram and save that in the kernel or save that in the disk. And then And then by the time I train it, I will load in the pre-compute master query to speed up, but it's still in progress. So essentially that's what I do. Yeah. Any question? Otherwise, I will close.
You said at the start that you were moving away from using Kaggle notebooks and like trying to put them into the repository. Are you using like, is it GitHub?
Yeah, I'm using GitHub.
Have you got that working now then? So do you use like a Kaggle notebook that pulls your stuff out of GitHub at the start?
Yeah, that's essentially what I do. So originally I have a...
Yeah, is that hard to set up?
It's not hard to set up. So right now, what I try to emulate, I'm in a real competition, right? I don't want to disclose my code base to others. So essentially I set up a private repository here.
Yep.
And then install my code. So, and then on the other hand, I set up a notebook that can git pull my code base. Let me get that notebook.
What would happen if you were say you were running in a, you get like the Kaggle competitions where the notebook doesn't have any internet access? Would you be able to use this? Would you be able to put your code into a data set and do it that way?
I think for this kind of competition, they have a constraint when you do a submission, but I don't think they have a constraint when you do the model training. Because for this part, I mainly do model training. So I think what you're talking about is in the inference, in the kernel that's responsible for the inference and submission, you cannot use the internet. So in this case, yes, I cannot do in this way, like, because I can't do any git pooling. So if you want to get this to work in this scenario, you need to, I think you need to save your script as a data set, as a Kaggle data set. And then you need to upload your data set there. But for that, I think it's more troublesome in the sense that it's hard to maintain your code base. I mean, by the time you make one change and then you need to manually upload that to a database again. I can't think of an efficient way to do that yet, but I think it's not the case in here. So I just use this way.
Okay.
So essentially what I do is, because the kernel, in kernel, I can save environment variable. So I can save my credential, like my username, password, and repository URL into my environment variable. And then I do a git clone, git pull, and then install my dependency here. And then what I essentially do is here I import all the necessary helper function here and then just run my code. So in this way I can. So I think in this way it's cleaner. I don't need to scroll infinitely long to look at my results. And
it's cleaner, and yeah, like I've done the same thing in Google Colab, because not only is it cleaner, but it means that you can sort of build up like a library of useful functions and classes or whatever, and then reuse them across competitions, as opposed to in the past I always used to end up cutting and pasting all my notebooks all over the place.
Yeah, I think it's pretty handy, right? So if I can get this to work, then I can do the same thing on Colab and on the Kaggle. So I have two different platforms to do the training. And also I can do that in GPU and TPU. So I can split to 4 sessions.
Yeah. And how would you edit the code that's in GitHub?
Add my code, what do you mean?
Yeah, so like this code here, do you just edit it in like Visual Studio Code or whatever, VS Code?
I mean, use Python.
Right.
So my workflow is something like I'll write my code in my laptop, and then I will git push my code, and then I will pull my code in my Kaggle kernel or the Colab, and then I will do the training. So in my local environment, I don't have much disk space, so I mainly just create some small data set to do some testing. And once the testing looks good, then I will push the code.
All right. Cheers. Thanks.
Any other questions?
No. Is the code you use to set up the GitHub public, Alex?
What do you mean?
The one that you just showed, that the notebook that you use for setting up.
Oh,
yeah, that
so I need to.
Was it this?
So the main setup is this block and this block.
Right.
So
right. Yeah.
I need to click clone and I need to set up a URL. But I want to make it private. So essentially, I need my username, I need my password, and I need my repository name. And then I can synthesize a valid, legit URL. And then I just click clone this URL.
Were you asking Srinivas, was this notebook public so as you could have a look at it?
Yeah,
that's what I was asking.
Yeah, because by using the user secret thing, that keeps your
you can
credentials.
Hide the, yeah, right.
Yeah, maybe I can just show you how to set this up. It's pretty easy, right? So you just click on the add-on secret and set this here.
Yep.
Yeah, I will send out the link.
Cheers, thanks.
Great, thanks.
All right, that's my part.
Anyone else? Want to share what they were able to get done this week? In my case also, it was, there were several distractions. I didn't do much at all. In fact, I struggled with something very simple. And then I think Steve thankfully helped out. But even after that, it turns out, so as I was saying last week, I just wanted to set up the infrastructure to be able to do the audio augmentations and just work in the audio space. I'd been working after conversion to the image space. And it turns out that, for that, I just wanted to resample, and resampling was taking a heck of a long time. And so I wanted to set up data sets, which I struggled with for a while until Steve helped to, there were like a couple of little problems of creating a directory. But even after that, I posted about it on Slack, that there's a simple way to create a data set. There's a command line interface oriented way which they talk about, and the notebook I was kind of looking at to do that, followed that approach. That didn't work for me, and Steve shared a different approach of where once you generate an output, then you can just go to the bottom left and just create a data set from it, and it processes. But even in that process, I found out that further hurdles, in the sense that there's a 20 gig limit on output. So I tried, in fact, the first time after Steve helped me, I still tried to generate all of the entire test data, which is about 4,700 or 4,000 something IDs, record IDs, into sound files. That overflew the disk. So then I had to chop it up into multitude of tests and train. I had to chop it up into pieces. But what is strange is...
Did you zip your output?
Yes. So each of the zip thing still turns out after zipping, I think the audio files seem to be large because they are NumPy files or whatever. They are NumPy files. But, after zipping, it's still about 1,000, like you had done, Steve, I chopped into about 1,100 files, 1,200 files, so thereabouts. And that's...
Because I was able to generate mine all in one notebook when I zipped them up. The reason I put them into like 5 different zip files was because of the fact I wanted to download them afterwards to use at Colab, and if it was like just one 20 gig zip file, it wouldn't let me download that. But yeah, I could use one Kaggle notebook for all of the output.
But was your output NumPy files or was it images?
NumPy files.
Huh. Because yeah, I did zip, using the shutil zip thing.
Yeah.
But even after zipping, my each of the 1200 or so chunks was about 8 gig.
Maybe you were you using like a higher sampling rate or something? I was using, was it?
No, lower actually, right? The 4800, I was reducing it to 32K.
All right, yeah, because that's what I use as well.
Yeah, that's really strange then. Why my if it's NumPy files, that's really puzzling. Where you said your NumPy files are 32K, but it was able to generate all of the output within singles. How big is your total? So did you use one for train and one for test, or everything was in a single?
Everything was in a single notebook, and yeah, the notebook I used, I basically just got it from somebody on the discussions or whatever. So I can find the original notebook that I copied from. Yeah, because his puts everything into a single notebook for everything, and he's working at 32,000. I'll just.
That's really weird because I'd like to debug why.
Yeah.
I'm having. So I ran, the fixed notebook or the minor issues that you helped me fix, and then I ran it. And the first time I ran, it was like successful. So I went to look at the output, and again there was no output, and I was like, "What the heck?" Then debugged it, and it said, "Oh, you ran out of this space." And when I looked at it, each of my output chunks is still about 8K for each of 1200. So, by the time I'm doing 3 chunks of the training, then it would overflow the 20 gig limit that Kaggle imposes. But what is interesting though is, so I thought I'm doomed with this approach, but what I found, which was interesting, is as long as you generate each chunk to be less than the 20 gig, it allows you to exceed the total 20 gig space, because my each chunk, like I said, of 1200 files or thereabouts is 8 gig. So I still have for the 4 training chunks 32 gig, and that's okay. It allows you to upload those 4 individually as data set, but it doesn't let you do a single file disk write of greater than 20 gig. So that was something puzzling. Yeah. So if yours is also the NumPy files of the same sampling, then I am definitely doing something screwy, or I can't quite figure out why. And it is a zipped file because it stores it as a zip file, so it does successfully zip it. But even the zipped size is 8 gig per 1200 files, plus minus. I mean, it's 8 point something for one, 7.8 for another, and stuff. But it's in that range.
Are you aiming to run the whole thing in the kernel? Like you're not planning to write the big file in your local disk and upload it again?
Yeah, no, the reason for doing it was, converting it on the fly takes a very long, resampling it on the fly takes a very long time. So it's already resampled. So all I need to do is just read from or input the data set, and then I can just read the audio read the resampled NumPy files and use it.
And you said you have difficulty setting up the dataset because the file is too big?
Multiple things. The first attempt I made, it wouldn't even write the output, and that had to do with, I think, what Steve helped me debug was the fact that it wasn't creating the directory. And what was strange about it was when I was running it interactively, it would write the files to that directory, but so I could see the files when I was running interactive, but then when I saved and committed, then no output would be generated. And Steve kind of pulled out the creation of the directory out of my loop, if you will, and it's outside, and that seemed to fix the problem. Once you create the output directory and write it, then it seemed to write when I saved and committed. But interactively, it creates the file when it's within the loop. It's kind of weird, but that was one problem I had to overcome. But then once I fixed that, or Steve helped fix that, and it was successfully writing the output. But now when I ran it, and instead of, let me see whether I have, thing I can share to show you what I'm talking about. Let me see whether I can just pull up the notebook to show you guys what I was encountering. Just give me a sec here. Okay, so let's look at that one. Let's look at a successful one. Okay, let me know when you guys can see my screen.
Yeah, I can see that now.
Yeah. So the first part was, this was a chunk of code I was using from something I'd seen somebody use. So you see this path save make directory exist, okay, blah, blah, blah. And, I was just using 32k.numpy, but I think what Steve showed was, I was using earlier a /temp, which, by the way, FYI, for you folks, I mentioned it in a Slack post, but temp folders go away when you close the notebook. So I think even if you create it and save and commit, and then they just disappear, so that's not a good thing to do. So but I had already made this change, but what Steve added and pointed to me was to create it outside of the loop, which still don't know why creating within the loop seems to not create it. And when I run this interactively, it successfully creates the file regardless of whether I have it outside of the loop or inside, which is again. But anyway, now the thing works, and you can see that the file is, or the folder is created. And I made this train 1, train n within this folder because I create this files list, and if I just run without this particular line and don't chunk it, then it overflows. Meaning, and then obviously once you run it, what Steve showed me was, on the left-hand side here, you get, do you want to convert to, or at least 3 tabs, and one of them says new data set, and you can just click that, and it asks you to name the data set, and it successfully produces the output like right there. So you can go and not right now, it doesn't give you the option, but once you successfully run it, and you can see, Steve, that it's zipped. but the zip file is this large. How big is your single file that you generate of all of the?
Yeah, so I just shared mine with you there. I'd put it into the chat. Yeah, so I create actually 5 zip files, like one for the test data, and then split the training data into 4 separate zips. So in total, mine comes in at 10.2 gig for all of the files.
Oh. Wow. See, that's what I was, and you also, from what I saw, you also just do a NP save, right? I mean, it's kind of very
right.
similar. I mean, this code is not that complicated, so it's also the same thing.
Yeah, no, my code would look the same as yours.
Too, right?
Yeah.
That's really weird.
Yeah, so I've shared my notebook now, so perhaps you could compare mine with yours later and see what the difference is.
Yeah. I'd like to do that because I was like, man, this is why.
Do you like I notice in my code, so I zip the files up and then I remove the tree or whatever. So I make sure that all of the other ones are removed.
Yeah, this one, right? I followed your
example. Yes. So I'm not sure then, but
that's weird because I had to, like after we fixed the problem, I still ran and it still didn't work, and then I had to debug, and it told me that I'd run out of disk space when I tried converting all the files, and I was like, what? Why? And then I figured, oh, the 20 gig, and yeah, sure enough, when I split it, but that's weird that in your case that doesn't seem to happen.
What's your
thanks for sharing.
What's your nmels value? Do you have
128?
All right, yeah,
but actually, see, that's the thing, right? I don't even do. By the way, that's why I was confused. The nmels would only matter here. All I'm doing is just resampling and storing the audio file itself. Now, I'll look at your, or maybe you can even just share. I'll stop sharing your notebook if you have it handy. Because if the nmels would matter, you do that in the audio.
Yeah, so I'm using these values, which is what the original notebook had. I notice here it says 1600, but I presume I'm calling this with the 3200. Yeah, so it's calling it with that, but yeah, so like my routine here looks very similar to yours, doesn't it? It's just loading the audio.
Yeah, except but aren't you storing the mel spec? In which case, the compute mel spec, is that a video? Is that an image thing, or what is the compute mel spec?
It's here, so it's.
Yeah, see, that's a spectrogram that you're showing. That's why it's so small. I think the wave files are much bigger. That's the difference.
So here's
yours is a spectrogram.
Is this not?
No, mine is actual audio files.
Oh, right, sorry.
They're wave files.
Oh, I thought you were computing the mel spectrograms and then saving the NumPy of that.
No, just raw audio. Raw audio, because I want to kind of move away from doing augmentation in the image space and try to do augmentation in the audio wave space.
All right.
So that's why I would, yeah, because that would explain, like, that's what I was saying, that, to me, mentally, I thought the model I had was, oh, images are so much smaller and so much easier to deal with than wave files then, because these wave files are huge. So this confirms what I was believing, right? Which is the image files are much easier to work with once you get into the spectrogram space. Whereas I was I remain in the wave or audio space. And that's
right.
why my files are huge.
Yep. Okay. That'll be the difference.
Yeah, thanks. That helped. Yeah, so I had to chunk and, you know, create these. And hopefully now I can, you know, I still have to read them in pieces, but hopefully that's not a major issue. But that's all I was able to do this week. I did something else, but I would wait for a week more until Steve makes submissions and a few more things before I kind of, since I had some time on my hand as I was struggling with getting the data sets done. So I kind of also compiled the thing I usually do after we have made submissions and kind of reached a particular level. So I looked at like the top end submissions and created a spreadsheet of their scores and the approaches they were using and things like that. So we can kind of stare at all of that in one place, but I don't want to share it yet until another week or so goes by and Steve also gets to submit and see what the score is and the approaches and results before we look at that.
Just a question.
And in this instance, unlike, sorry, go ahead, Alex.
I'm just wondering what would be the timeline for this competition practice? Like, in your estimate, when were you going to wrap up the whole thing?
Yeah, I think, you know, typically I would say we are kind of close, maybe a few more weeks. Just, you know, I'd like to give Steve a chance to make some submissions and try a couple of different approaches. So hopefully if he is able to do that as well next week, and then look at, and I hope to have at least gotten to like the mid-90s maybe by next week, because my data set is created. So now at least I can move to the next step, and we'll see. You know, you have reached like around close to 0.9, I think. And so at this time, I typically we look at, okay, what are all the top approaches that people have tried, and see whether there is any way that we can quickly emulate and or apply those techniques and see whether we get much better. So maybe a couple of weeks for that. So after next week, maybe a couple of weeks. And then if there are any specific papers or techniques that we have encountered, which in this case doesn't seem to be a whole lot, but at the same time, you know, I think one of the things I had bookmarked some time back was kind of understand the difference between REST, or at least look at the technique for the REST nest paper, because that seems to give better results than just a good old RESTnet. So maybe we'll give a couple of weeks to try techniques after next week, and then a week for, you know, any references or something, papers that are explicitly applicable to this technique, or you know, any new approaches to audio spectrogram analysis that have recently appeared, or kind of which techniques allow state-of-the-art approaches. Maybe a week or so for that, at most another 2 weeks. And so I think we should be done, all said and done, with maybe maximum of 3-4 weeks. And there is a July 4th weekend in between. So I would still say maybe a month, 4 weeks from today, we should be done with it. And typically toward the end, or when we are reading papers, we kind of put out a call for, okay, what's the next comp that people would like to go and participate or try their hand at. So I would say we're staring at 20th June, so maybe by mid-July we should be done with this, including looking at some of the resulting best techniques and or papers related to this competition. That would be interesting.
Okay, thanks. But I do just one note is I do see there's quite a number of reference we can take. about the top solution. Something like, because I also briefly looked at that, something like the coordinate convolution is some top player try to use it. Essentially, convolutional network trying to do some translational invariance, but in this case you don't want to apply that, so you try to add some coordinate information into the convnet. Another thing I see, which is pretty common in audio competition nowadays, is the SED. I think it is abbreviated as event. What's the name? Sound event detection. So I think it's a new architecture, something like that.
Yeah, and yeah, so those are things. The one difference I would say, without revealing the detail, I'll share them next week. I mean, I have the table prepared. It doesn't. I obviously, each of the links that I share will have all of the details. I just compiled and kind of pointed to their scores and whether they have the code or not and stuff like that. So it makes it easier for people to go look at it if they want to and stuff. And I'll share that next week. But the one comment I have is I think there's a lot less number of more number of people have posted their approaches in this competition than others that I've seen, and less number of people who have actually shared code that you can take a look at. But at the same time, there is at least still half a dozen or so code repositories that you could still look at, which are all getting fairly good scores in the 0.9 plus minus range. So I'll share all that next week after we've had the time to make maybe a couple more submissions. And at that point, we'd be on kind of like the last 2-3 weeks of discussing, where else, and at least now that everything is open, can we still get any improvements by adopting any of those techniques? And then, after about a couple of weeks of that, we just see whether we can look at any papers like SCD and anything else that, another paper or another technique that we have discussed, even Arto had pointed to previously, is the student-teacher learning and knowledge distillation. Again, I haven't seen some good code and going through that in detail. That will be another good paper, or if we can find something which has the accompanying code and somebody can go through and present. So those are a couple of things that come to mind, but there may be others, like you say, and we'll spend a week or two doing that and in parallel ask for suggestions from people of the next competition to go to. So I think by mid next month, we should be done with this one.
All right.
Okay. Thanks everybody for joining, and see you all next week, same time. And I'll post the recording shortly.
Okay, cheers. See you next week.
Yeah.
Thank you.